About these flip-flops in your earlier classes, maybe in MSc or maybe in BSc also. Okay, so you normally a flip-flop is written like this, block diagram like this. Say flips. The circuit was having two input. One is set, one is correspond to reset, and output one is termed as Q and another is Q bar. Okay, and normally the function of the circuit was like that. Say if Q is equal to 1, then Q bar must equal to 0, and we say this is equal to set. Okay, and if Q is equal to 0, then Q bar is equal to 1, and we say the system is in reset. Okay, so initially system is in 0. We have set in high states, that is so that output gives a 1. Here we say 1 is set. Okay, similarly again it's possible to reset 0. Okay, so this is normally termed as the basic memory. It's a sequential circuit because output always depends on the previous input. It's on a follow some sequence. So this is sequential circuit. Okay, and this gives the conception that it can remember the not only the instantaneous input but also the earlier output also. So some kind of memory is related, and this gives the idea that this acts like a memory. Okay, so we have seen this kind of circuit can be designed using NAND gate, say like this. So this is two NAND gates. Say this is your output. Like this, S, R, Q, Q bar. Okay, so this is a simple flip-flop circuit using NAND gate. So, and the function table was like that, say S, R, and Q. So, if we give 0, 0, 0, 0, NAND gate normally 0, if you give 0 to any input, irrespective of other inputs, output will try to be high. If it is NAND gate means output will try to 1. Okay, so in that case, if S and R both are 0, then output both Q and Q bar will try to be 1. Okay, but according to our this assumption or design of the circuit, it is unexpected, and this is also unexpected because if here 0, here also 0, so due to this 0 here it is 1, due to this 0 here it is 1. Okay, so this will again go here, so again 1, 0, again 0. Okay, okay. So but both these two states never be as 1. So this is some kind of unexpected because we have designed the circuit for the objective that we should have either 1 or 0 in these inputs. Okay, so this Q and Q bar is always complementary. Okay, so we say that this is an uncertainty kind of thing, or question means it's invalid. We cannot use this. Okay, similarly, if you give 0, 1, you will have 1. If you give 1, 0, you will have 0. If you give 1, 1, it depends on the earlier inputs. Okay, outputs. Okay, that means Q 0. We say that this is no change. Okay, this is we say reset. This is we say set, and this is we say unwanted or invalid. Invalid means we cannot use this. We don't want this. Okay, so this is a basic system. Okay, similarly, you can design the same thing using OR gate also. Okay, now whenever there are this kind of circuits, before starting on, switch on, the circuit always should have some kind of states. State means either input as 00 or 11, something like this. Okay, and as soon as you change, then your output will change. Okay, so depending on this, that is in resting condition, how the circuits should be. There are two types of systems. One is called active high. Okay, active high, or one is another is active low. Okay, in case of active high circuits, normally set and reset inputs are kept in low states. Active high, okay, here in low states. Okay, so as soon as any of the inputs are switched to one, that is become high, the output will change. Okay, so that's why this is called active high. So normally they rest as initially inputs in kept as 0, s is equal to r is equal to 0. Okay, active low means initially the circuits, initially for these circuits, inputs are kept s is equal to r is equal to 1. Okay, in high state, they in rest or idle conditions, inputs are kept in high states. As soon as you change any of its inputs from high to low, your output will change. That's why it's called active low. Okay, so this is two kind of flip-flops. Mainly, this is valid for all kinds of flip-flop, depending on your resting or idle conditions. Okay, and normally this, whether your circuit will behave as active high or active low, it depends on these conditions. Okay, so normally, because normally always we want that our output, whatever is there, it should not change. It should be stable. Okay, in rest condition, unless until we want to change it. Okay, so that's why normally any this kind of circuit is always inputs are kept in such a way that output should not change. Okay, so in that case, this circuit normally in resting condition input should be 1 1. That is mean here. As soon as you made any of these two inputs as 0 or low state, your output will change. So this is an active low. This is an active low circuits. Okay, so if you draw same circuit using OR gate, then you will see your this function table will just reverse. 0 0 is no change, 0 1 is equal to it gives you output 0, 1 0 give you 1, and 1 1 will be uncertainty if you replace this NAND gate using NOR gate. In that case, the circuit 0 0 is no change, so that circuit is an active high circuit. Okay, because normally in ideal conditions you are putting your both the inputs in zero low states. As soon as you want to set or reset, you change any of its input from low to high. Okay, this circuit, in this circuit, say this is resting in high states, it will become active as soon as any of this one will go to low state 0. If you want to set this circuit, what you will do, this you will change this to 0. If you want to reset it, you will change it to 0. Okay, so it's active low. Okay, so this is two type of circuits. So is it clear, Shilpi?
Yes, sir.
Okay, so now you design. This is a active low circuit using NAND gate. Okay, now you design a flip flop which will be active high. Okay, active high. What you can do, you can replace this NAND gate using NOR. Automatically it will be active high. But I want you design an flip-flop using NAND gate only, which will act like active high. Okay, so my question is clear?
Yes, sir.
Okay, so you please try to design it. Okay. And normally you have to design a circuit using NAND gate in such a way that where your 0 will be as no change conditions. Then you can make your circuit in resting condition as input 0. Okay, so active high. So this is what I want you to make. Sagorika? শিল্পী করতে পারছো নি?
হ্যাঁ স্যার, করছি।
Okay. So simply how you can achieve it, you just put here, okay, this is NAND gate as not, okay, here also, okay, now S R. Now you check the function table, okay, simply you add two NAND gate in the inputs of your circuit, then you check the table. Okay, and you will see that this table is reversed. Okay, this table is reversed. You will see for 0 0 this is no change, Q0 is R Q, and 0 1 0 1 0 1 1 1 your uncertainty. Okay, so this is a circuit which will rest in low state and it will become active whenever you change any of your inputs from 0 to 1. For example, if you want to reset, you will change this R to high. If you want to set, you will change your S to high. Then you will have either reset or set. This is unwanted. Okay, so this is how you will do it. Okay, so uh, then say now you have you know this whether it is active low or active high circuit. If normally your inputs will rest either both in 0 or both in high. Okay, if both in high, this is active low. If both in 0, this is active high. Okay, so this is okay. But in this circuit, one issue is that by any means, if your input is changed due to any unwanted issue also, then automatically output will change. Okay, so to avoid this, to control this, what has done, some kind of extra input was given like this. Okay, simply like this, then this, তোমরা এটা আগে থেকেই জানো, তো আমরা একটু রিক্যাপ করে নিচ্ছি। Like this is your S, this is your R. We say this is clock input. Then this is Q bar. Here, this is an active high circuits. So normally output will normally inputs are kept in 0 0. Say if we write the function table S R Q. Okay, so 0 0 no change, Q0. 0 1 is 0 reset, 1 0 is 1 set, 1 1 we don't want it. Okay, but here by putting this clock pulse, if C is 0, that means irrespective of S is 1 or 0 or R is 0, so output is always 1. Okay, so irrespective of S or R input. And if here in this circuit, if 1 1, you see this is an active low case, this one 1 1 is no change. Okay, so output will not change. So just putting controlling clock pulse, this is called clock, another pulse to control the circuit, it will function. Even if you change S and R, your output may not change depending on your control inputs C. Okay, so by this, if C is in this circuit, if your C is says C, as long as C is high in high state, okay, your output will change. This is valid. This is valid. Okay, so this circuit will, or this function table 0 0 no change, 0 1 0, these things will be effective or functional as long as your clock pulse is high. If clock pulse is 0, say this is 0 means like this, we say 0 low state. Okay, so this part low state, this is your no change. Output will always Q0, irrespective of these two inputs. Okay. So by just giving this one, you can control. Okay. So regarding this symbol, actually, we in this digital system, electronics, normally okay. So normally this circuit, any signal in digital systems, whether it is input or output, it is represented as a combination of 1 and 0. 1 and 0 means how long your system is in 0 or 1 state. So this is some kind of combinations of, say, this is your high state, say V is equal to V, this is your 0 state. Okay. So how you will represent if you time is in these directions, so say like this. Like this. Okay, these are straight. আমার আগ থেকে এরকম গন্ডগোল হয়ে গেছে, এগুলো হচ্ছে স্ট্রেইট, এরকম এরকম স্কোয়ার হতে পারে। এখান থেকে সে T1 to T2 T3 T4. So here we can say that from T1 to T2 the system is in high state. Okay, from T3 to T2 to T3 is in low state. Here again high state, here again low state. It's like that. Okay, so how long you want to have your circuit in low state, high state in the input, by changing the width of the pulse you can design. Okay, and normally you will also define a particular width for your 0 or 1. Okay, and it should be symmetric for all the cases. Otherwise you cannot differentiate between say 2 0 or 2 1. Okay, you cannot say that it is half 0 or half 1 like this. So you have to define the, yes, my duration is T dash, this is always 1 if this time period is high. If this time period is 0, this is 0. Okay, so in this way you have to define your input or output. Okay, so this is your clock pulse by which you can control the input and output. Okay, so this is one part. So now we see that if we give this input and output, then in these two inputs, change these two inputs, then depending on clock pulse, output will change. Now we know that, or we can control this one. Okay, so as long as this is high, clock pulse is high, your output will change. Okay, now based on this criteria, there are again two types of flip-flop. One is called positive S-triggered flip-flop. Positive S-triggered flip-flop, another is negative S-triggered flip-flop. Say your clock pulse, say this is your clock pulse like this. Okay, so this is your clock pulse. So normally up to now we know that as soon as if you are go on changing inputs, যদি তোমার এই জায়গাতে চেঞ্জ করো এই টাইমের মধ্যে, তাহলে আউটপুট উইল চেঞ্জ, অর এই জায়গাতে চেঞ্জ করলে আউটপুট উইল চেঞ্জ, অর এই জায়গাতে চেঞ্জ করলে আউটপুট উইল নট চেঞ্জ। ওকে, বাট দেয়ার ইজ এ মডিফিকেশন কি, নো, আমার এই ডিউরেশন নয়, আই ওয়ান্ট যে only when clock pulse changes from 0 to high, that is during this system, this transition from 0 to 1, output should change. So this is, in that case, this is called positive S-triggered flip-flop. And normally কি বলে, clock pulse are designed বুঝানো হয় এরকম, this is symbol of positive S-triggered clock pulse. Just by observing this arrow, you can say that yes, this is a positive S-triggered flip-flop. মানে কি, the output will change during the, based on the inputs during the transition of clock pulse from 0 to high. আবার আরেকটা হতে পারে এরকম যে কি, like this. এখানে কি, this is called negative edge triggered flip flop. তার মানে কি, শুভজিৎ না, negative edge triggered flip flop তার মানে কি, your output will change when your clock pulse transit from or switch from high state to low state. This is called negative edge triggered flip flop. Okay, so in that case, what you have to do, you have to design a small circuitry for your clock pulse, because normally if you simply give this kind of signal to your clock, then automatically your output will change based on this, as long as your clock is high. But we want output should change during this transition or during this transition. So we have to have some kind of mechanism so that my clock should remain high only during clock means here output of the clock should remain high during this transition or this transition. So for this we need to design some small circuitry. Okay, so generation of narrow spikes both in positive edge or negative edge. How we will do that? This is very simple. So simply using AND gate, we can do that. So this is my clock. So this is my output. So if I now draw the output of the circuit, what we will have, say we are giving a square wave signal here like this. Then has a. Okay, so this is my normal clock pulse. Okay, so C bar here, this is C bar, that is invert, not gate dile input e ekhane jodi high hoy ekhane hobe 0, ekhane 0 hole ekhane 1. Okay, so as long as we have, this is low, this is 0 state, this is 1 state. Okay, this is 1 state, this is 0 state. As long as 0, your output for C bar output is high like this. So এখানে গিয়ে ইনপুটটা হাই হয়ে গেছে, তার মানে আউটপুটটা 0 হইতে লাগে। However, due to propagation delay of this circuit from এখান থেকে এখানে 1 হলে এখানে 0 আসে, কিন্তু যখন এটাতে 0 করবে, এই 0 এখানে যাইতে যাইতে একটু টাইম লাগবে। তার মানে যে due to propagation delay, what we will see that এখানে গিয়ে আমার আউটপুট 0 হওয়ার কথা না হয়ে এখানে গিয়ে 0 হচ্ছে। সিমিলারলি এখানে গিয়ে হাই হওয়ার কথা না হয়ে হাই হচ্ছে এখানে। Okay, so this time period is mainly due to propagation delay. Okay, so in that case you see that this is C bar, means this signal, and this one is C, this signal. So you will see that for this small time period your both the input is high. That means you will have a output like this. Okay, so this is your output. So if you give this small circuit in your clock pulse, then you will see that your output will change only during this transition. Okay, this transition, because your this is remain high only for this small triggering pulse. Okay, So automatically at that time, your circuit will search what is its input. Depending on the input, automatically output will change. Okay. Similarly, you can design your, this is then for positive SD card clock pulse, what we will do, we can simply give a clock pulse circuit like this. Similarly, for negative SD card flip-flop, what we can do, we can replace the clock pulse part with a small circuitry like this. This is NOR gate. So this is your C, this is C bar, when it has C. So this is your output. So let's draw how it looks like. So this is the clock pulse C. Your output will be, sorry, how delete it. Difficult. আবার বললাম erase কি করে So you will see this is your clock bar, this is your output. Okay, so if you use this circuit in your flip-flop, your circuit in the main circuit here this time period will get as the high signal. It's a triggering because very small width. So during that time, depending on your input, your output will change. Okay. So we have now we know that we may have two types of flip-flops based on the triggering edges. In one case, what we can do, we can design the circuit so that my output changes during the positive edge of the clock pulse. In other case, the output change during the negative edge of the clock pulse. Okay. So this is then two systems. Now we have one issue that in these circuits, in both these active low or active high, whatever may be the case, one problem is that either 00 or 11 we don't want. When the output is trending towards high, both the output, we don't want it. Okay, but unknowingly এরকম হয়েও যেতে পারে যে either based on input 00 or 11 output maybe tends towards high, but we don't want it. So we want modifications, and how this can be achieved simply by modifying the flip-flop circuits, and this is your JK flip. I am not going details. If you want, you can ask me, then I can go. Simply what we will do in JK, we have our SR flip-flop like this. Say this is my Q, this is my Q bar. Then I will these are AND, J, K. What we will do, here. Okay, and this is my clock pulse. So this is some simple modifications, and this is your S, this is your R. Okay, so we modified in such a way that S is equal to J dot Q bar, R is equal to K dot Q. Now externally, with the help of J and K, we can control these circuits. Okay. Now if you analyze in detail, so I am not going in details, you will see that this table will have a function table like this: J, K, Q. Okay, or like this: J, N, K, N, Q, N plus 1, or J, K, Q. Like 0, 0, we have no change. That means Qn, previous state. Okay. 0, 1, we have 0 reset. 1, 0, we have 1. And 1, 1, we have Qn bar. Okay. 1, 1, we have Qn bar. Okay. So this here you will see that no problem with respect to our earlier issues, that is in certain cases 1, 1 in the input or 0, 0 in the input, leading towards unwanted conditions at the output. That means either both the outputs tending towards high, which is unwanted as per the assumption or construction of the circuit. This can be avoided just modifying this your SR flip-flop simply like this. Okay, so this is your JK flip-flop. But in this flip-flop, again there is one problem. One problem is we see that when 0, 0, no issue, it's unchanged. It can hold previous state. 0, 1, reset. 1, 0, set, no issue. But if it is 1, 1, if it is 1, 1, then output is just reverse of the earlier input, Qn bar. If in earlier cases, if your output is 0, now it will be 1. If it was 1, then now it will be 0. Okay. So say by somehow you have given J is equal to K is equal to 1. Okay. And in earlier cases, here it was 0, it was 1. So due to these inputs, আমার এখানে 0 জায়গাতে 1 হয়ে যাওয়ার কথা, এখানে 0 হয়ে যাওয়ার কথা। But as soon as এখানে 1 হয়ে যাবে, সঙ্গে সঙ্গে এই যে due to this feedback, it will come to the input also, and due to this path, 0 will go here. Okay, so that means automatically you see if here 0, if here 1, then what will happen? The circuit may sense that yes, my output is 1 and input is 1, 1. So since output is 1, what I have to do, I have to just change the state. 1 এর জায়গাতে 0 হয়ে যেতে হবে। আবার 0 যখন হয়ে যাবে, যদি if circuit can sense that yes, output of the circuit is 0, automatically it will go to 1. So as long as your input, say this is your input pulse, duration of your 1, say this is your, say, pulse width, and তাহলে কি হবে, up to this time period আমরা কেতে 1 দিয়েছি, যেতে মানে এই টাইম অবধি আমরা 1 দিয়ে রেখেছি। ওকে, সো যদি during this time period if output changes and it can come to the input, then automatically output again will change. That means it will toggle, it will try to change simultaneously in between 0, 1, 0, 1. 1 hole সঙ্গে সঙ্গে at the same time it want to be 0, 0 hole 1 হয়ে যেতে পারে। There may be a race kind of situation. This is called race around conditions. Okay. So how this can be avoided? There is a simple way to avoid it, say, because once you are giving here 1, it will go here, okay, and it will read the output, earlier output. So signal has to pass here, or for reading it have to come over here, okay. So if you want to delay this passage, that means if you can linger the propagation delay up to this pulse width, then this toggling, that is race between 0 and 1, may be avoided. But in that case, circuit performance will be severely affected because your propagation delay would be very high. Okay, so it's not a feasible system. So simply by increasing the clock pulse width, by propagation delay up to the order of width of the clock pulse, one can eliminate this. Okay, but this is unwanted. So in order to avoid this, what designer has done, they have connected 2 JK flip-flop. Okay, 2 JK flip-flop like this, simple. Say this is 1 JK, this is another JK. Okay, so they directly connected in series. This is output. This is the input. Say J1, K1. This is your J1, K1, Q1, Q2. This is your again J2, K2, Q2, Q2 bar. This is not Q2. This is Q1 bar. Okay. Then what they did, they connected a common clock pulse like this using a NOT gate. Okay. Normally, if you look into this table, you see 0, 0, no change. 0, 1, output is 0. 1, 0, output is 1. Okay. That means if you give here 0, 0, your this portion will not change. Okay, so here also same thing will go. So depending this, you will have output, so no change. Okay, so 0, 1, again here also 0, 1. So here also 0, 1. So output is 0, 1. 1, 0, 1, 0, 1, 0, output also 1, 0. 1, 1, output is inversion. That is 1 থাকলে 0, 0 থাকলে 1. তো এখানেও সেম হবে, চেঞ্জ হতে থাকবে। এটা চেঞ্জ হওয়া মানে এখানেও চেঞ্জ হতে থাকবে। বাট হাউ উই হ্যাভ কন্ট্রোল দিস আর্লিয়ার ইস্যু, যে ফিডব্যাক হয়ে যেটা যাচ্ছিল, আমরা কি করেছি যে দিস 2 সার্কিটস কানেক্টেড ইন সিরিজ, কিন্তু ওই ক্লক পালস মাঝখানে কাট করে দিয়েছি। যে ক্লক পালস একটা দিয়েছি, এটাতে যদি হাই হয়, whether it is positive SD card অথবা নেগেটিভ SD card, তাহলে এটাতে লো থাকবে। তো লো থাকা মানে এটা অফ, আবার এটাতে যখন লো হবে তখন এটা হাই। তার মানে কি, তা এখানে যা দিয়েছি আমরা প্রথম ক্লক পালস, এটা এখানে যাবে। পরের সিস্টেমে যখন এটা লো হয়ে যাবে, সঙ্গে সঙ্গে এটা হয়ে এটা এখানে যাবে। তার মানে এখানে আমরা যে ইনপুট দেব তার বেসিসেই এটা চেঞ্জ হবে, কিন্তু দুইটা ক্লক পালস পরে, একটা ক্লক পালস পরে এটা যাবে, আর এই আউটপুটটা যাবে আরেকটা ক্লক পালস পরে। Okay, so that means this flip-flop will follow or carry the output of this flip-flop just after one clock pulse. Okay, that's why this system is called master slave, and this one is slave, and this is a master, because this will follow this one. Okay, after one clock pulse. So this is simple modifications how you avoid this earlier problem. Okay. Then we have delay D flip-flop. In D flip-flop, it was simply a case like this. Say your JK or SR, whatever may be, simply like this, you will give like this. Okay, so this is your D, এটা S hook, S R অথবা JK, no problem. This is your output. Okay, so what if you give here 1, you will see that here 1, 0. So 1, 0. If you give 0, 0, 1, so output is 0, 1. Okay, but that means you can transfer this input to this output after 1 clock pulse. So you just transmit your inputs to the output just of the order of delay of 1 clock pulse width. That's why it is called delay flip-flop. But it has a lot of use. We will see with some example in later parts. Okay. Then there was another issue, say for any, whether it is JK, it's master slave or SR flip-flop, we want to have a pre-stored conditions, set or reset. So how we can do it? Simply, it was done simply by putting some inputs here. Okay, preset or clear. Just putting, say, this is a preset, this is clear. Okay, so say if this is 0, then irrespective of any other inputs or any other values, this is always 1. Okay, so if you want to preset, আগে থেকে সেট করে রাখতে চাও, তাহলে PR is equal to 1, CR is equal to PR is equal to 0, CR equal to 1. If you want to do the reverse, then ultata তুমি করে দিতে পারো. Okay, so you can these are some advantage. You can control the earlier stored information, pre-loaded or pre-loading system. You can do it. Okay. Now there is another kind of flip-flop. This is called T kind of T flip-flop. Okay, so what is this? Simply, I my say JK flip-flop I have. Okay, so what? This is J, this is K, this is your clock. Okay, clock. এগুলা সিম্বল যেটা preset for reset মানে clear. This is your Q bar, this is your Q. Okay, so in this circuit, what we have, say, this flip-flop will act as a toggle switch. Toggle means it will continuously switch between 0 and 1 as soon as t is equal to 1, depending on the clock pulse. How? Say if your t input, say if you write the function table, say tn 0, then your output qn plus 1. If it has 0 হয়, তার মানে 0 0 0 0 মানে no change. Your output will be the earlier state, because in JK flip-flop 0 0 means no change. But if it is 1, then your J is equal to 1, K is equal to 1. So depending on the earlier state Qn, it will be Qn bar. Okay, but it will depends on the clock pulse. Okay, as soon as clock pulse is high or during the triggering edges, it will automatically move from Qn to Qn bar, পরের বার আবার Qn হয়ে যাবে. That means it will like this Qn bar at the clock edges অথবা clock as long as the clock pulse is high. So this kind of, it will toggle between 0 and 1. So this kind of flip-flop is known as T flip-flop, and we will see that this is also has some kind of use in later parts. Okay, so now I uh, want to tell you to, I want you to design a toggle switch. This is toggle switch, okay? That means switch between 0 and 1 continuously. So I want you to design a circuit to with SR flip-flop to have this kind of functionality, toggling function, okay? So Sagorika এসছে না আসেনি আজকে? Absent. Sudeep? Shibujyoti?
Yes, sir.
ওকে, সো ইউ ডিজাইন, বুঝতে পেরেছো যেগুলো আমরা আলোচনা করেছি?
হ্যাঁ স্যার।
ওকে, সো নাও ইউ ডিজাইন এ সার্কিট ইউজিং এসআর ফ্লিপ ফ্লপ উইথ টগলিং ফাংশনালিটি। পড়ো। So this is my SR flip-flop. I have like this. Then I have this. This is my S. This is my R. This is my clock pulse. Okay. Now, if 1 0, we may have 1 0. If 0 1, we may have 0 1. Okay. So depending on whether it is active low or active high. Okay. So what we can do, simply we can have a feedback like this connection. Then like this. Okay. So whether it is active low or active high, it doesn't matter. If say you give 0 and 1, you will see 1 0 and 1, you will see your circuit here 1, because if it is say active low means earlier it was 1 1, then no change. Okay, so 0 1 means your output will change. Say 0 1 means 0, here 1. Okay, yes, automatically in the next pulse you will see, due to this feedback, 1 will come here, 0 will come here. So 1 0, again 1 0, then 0 will go here, 1 will go here, then 0 1. So like this it will go on toggling. Okay, 0 to 1, 1 to 0, 0 to 1, like this. Okay, so Q to Q bar continuously. So this is a toggling switch using SR flip-flop. You can have a toggling function using SR flip-flop also. Now, say, let us draw a small problem. So write down, please. The two inputs applied simultaneously to a negative S trigger JK flip-flop. The two inputs applied simultaneously to a negative S trigger JK flip-flop at J and K are 0 1 1 0 1 1 1. This is LSB. This is your MSB. This is one input. J and K is 0 1 1 1 0 1 0 0. This is your LSB. This is your MSB. Okay. So two inputs applied simultaneously to a negative S trigger JK flip-flop at J and K are একটা হচ্ছে এটা আর একটা হচ্ছে এটা, respectively. Write the Q output corresponding to each of the J and K input bits. Draw the timing signal. Assume QB reset initially. Assume QB reset initially. লিখতে পারছো?
হ্যাঁ স্যার।
Okay, so now you try to do that. So what we have to do, first we have to draw J and K signal. Okay, so this is the time axis, this is the amplitude maybe. So J, it is given as 1 0 1 1 0 1 1 1. Okay, so this is my J. So প্রথমে 1 আছে, সে আমরা ধরে নিলাম এটা 1, এই টাইমটা আমরা 1 ধরে নিয়েছি। ওকে, সো 1 এর পরে আছে 0, তার মানে ঠিক একই সমান ডিউরেশন, এই সমান ডিউরেশন 0 আছে। ওকে, এরপরে 1 কয়টা আছে? 2টা, তার মানে ডাবল। এই 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 যে ডিউরেশন, এটা হচ্ছে 1 অথবা 0 উইডথ, এটা ডাবল। মনে করো এটা হচ্ছে একটা, আরো একটা, সে ডাবল এতটুকু, এই ডাবল সে এতটুকু, 1 1। এরপরে হচ্ছে 0 দিয়ে 3টা 1, সে 0 মিনস আবার সে আমরা ধরে নিলাম এই, এরপরে সে একটা 1 আর একটা 1, সে এই 3টা 1। সো দিস ইজ ইয়োর, এটা হচ্ছে আমার কি সিগন্যাল? 0 1 0 1 0 1 1 0 3টা 1। ওকে, সো দিস ইজ মাই 1 0 1 1 0 1 1 1। Okay, now I draw na koi this is J, this is K signal going to give in the K, that is 0 3টা 1। প্রথমে আছে তোমার কে 0 3টা 1, সে তাহলে আমার এই এতটুকু অবধি হচ্ছে 0 0 1 একটা 1 3টা 1, মানে এতটুকু অবধি আসবে 0 3টা 1, এরপরে 0, তার মানে এতটুকু 0 0 1 0 0 1 0 0। Okay, so this is your 0 1 1 1 0 1 0, say 0। Okay, so this is my J and K signals. Okay, so based on this output will change, but since it is a positive negative ST-cut clock pulse, so only output will change based on the negative edge of the clock pulse. So let us draw the clock pulse here. Clock pulse, say this is arbitrary, say আমি ধরে নিয়েছি এটা আমার ক্লক পালস, কিন্তু উইডথ সব সমান হতে হবে। Okay, so this is a negative ST-cut clock pulse. That means we will give arrow here, 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 here. Okay, so that is my clock pulse. No, not bar. This is negative ST-cut. Okay, bar no, I mean negative ST-cut clock pulse. Now output will change. Say let us draw output here. Okay, so initially assume this is reset initially, তার মানে আউটপুটটা ইনিশিয়ালি এখানে আছে, 0 অবস্থায় আছে। ওকে, সো নাও কোন সময় চেঞ্জ হবে? এই জায়গাতে, এই জায়গাতে সবসময় এই জায়গাতেই সার্কিট উইল সার্চ যে হোয়াট ইজ দেয়ার ইন দ্য ইনপুট, অ্যাকর্ডিংলি আউটপুট উইল চেঞ্জ। যা বোঝার জন্য dot dot giving dot dots so that you can understand. similar way. Now, initially, your circuit is in, this is your output, মানে Q N, okay, or N plus whatever may be. So initially this is in reset condition. As soon as it will come here at the negative edge of the clock pulse, you will check what is in the input. You see 0, 1. 0, 1 means your output is again 0. So it will continue this same state up to here. Then again it will check. Here you see 1, 1. 1, 1 means যেটা আছে ইনপুটে তার উল্টা হয়ে সরি আউটপুটে তার উল্টা হবে কিউ এন বার। সো সঙ্গে সঙ্গে এটা এরকম হয়ে যাবে, চোখ বন্ধ করে এতটুকু অব্দি চলে যাবে। এখানে গিয়ে যেহেতু আবার নেগেটিভ এজ এসে গেছে, আবার চেক করবে ইনপুটে কি আছে। এখানে এসে ইট উইল সি দ্যাট এগেইন ইনপুট ইজ 1, 1, দ্যাট মিনস আউটপুটে যা আছে তার উল্টা হবে। এখানে আছে হাই, তাহলে লো হয়ে যাবে। হয়ে গেল, হয়ে আবার চলছে চোখ বন্ধ করে এতটুকু পর্যন্ত। সবসময় ইট উইল চেক ইন দি এজেস আইদার পজিটিভ অথবা নেগেটিভ। সিন্স ইট ইজ এ নেগেটিভ স্টিকার, তাহলে এখানে দেখবে। এখানে আবার দেখছে আবার 1, 1 আছে ইনপুটে, দ্যাট মিনস এটা উল্টা হয়ে যাবে। এরকম হয়ে গেল কতটুকু অব্দি উইদাউট এনি চেঞ্জ, এতটুকু অব্দি এসে গেল। এখানে এসে আবারও চেক করবে ইনপুটে কি আছে। 1, 0, 1, 0 মানে আউটপুট 1। সো ইট উইল কন্টিনিউ দি সেম স্টেট টিল হিয়ার, দেন এগেইন 1, 0, 1, 0 মিনস এগেইন 1, এতটুকু অব্দি যাবে। এখানে গিয়ে চেক করবে কি আছে। এখানে 0 আছে, এখানে 0 আছে, 0, 0 মানে নো চেঞ্জ, আবার চলবে। তার মানে দিস ইজ ইয়োর আউটপুট। ওকে, সো ইফ ইউ ওয়ান্ট টু write the output word, this will be 0, 0, 1, 0, 1, 1, 1. So this is your output. That means for 1, 0, output is 0, 0, 1, 0, 1, 1, you see for, no, here, 1, 1, this is 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 0, 1. So this is your output and this is your output timing graph. Okay. So এখানে দেখো আমারটার সঙ্গে তোমারটা নাও মিলতে পারে। It will depend on this এই জায়গার উপরে আর এই ক্লক পালসের উপরে। সিম্পলি যে 1, 0 দিলে সবসময় আউটপুট 1 হবে তা নয়। নর্মালি 1, 0 মানে যে কে ফ্লিপ ফ্লপে 1, 0 মানে আউটপুট হচ্ছে 1। কিন্তু এখানে ডিপেন্ড করবে যে ওই সময় ক্লক পালসে ওটা চেঞ্জ করতে ও অ্যালাউ করে কি না, তার উপরে বেস করে। সো দিস ইজ দি টাইমিং ডায়াগ্রাম করসপন্ডিং টু দিস প্রবলেম। শিল্পী বুঝতে পারছো?
Yes, sir. বুঝতে পেরেছি।
Now one homework, prepare the truth table for the circuit shown below. Prepare the function table or the truth table for the circuit shown below and identify the function for low and high inputs. এই ফাংশনটার নাম কি সেটা এটা হচ্ছে তো XOR gate, এটা তো জানো। And identify the whole function for low as well as high inputs. This is homework. then 365. Then আচ্ছা ওটা আমি ছবি তুলে পাঠিয়ে দেবো হোমওয়ার্ক আরো যেটা তো ঠিক আছে আজকে এখানে আমরা স্টপ করব নেক্সট ক্লাসে আমরা উই শ্যাল কন্টিনিউ আওয়ার discussion. So if you have any query, you can ask me or you can go through. You can take help from the book Anand Kumar for this part. So, Shubhajyoti, any issue?
না স্যার।
Okay, তাহলে বন্ধ করে দিচ্ছি তাহলে।